Hey everybody, welcome to our lesson today. Today we're going to continue our discussion on how we name ionic compounds. In our previous video, we spent a little bit of time talking about how we name just basic binary ionic compounds, but we also did take some time to talk about those polyatomic ions or compounds that contain more than two types of atoms. We're going to continue this discussion to focus a little bit more on the metals that form multiple charges. So I know this question came up in class while we were working in our pair deck about, with the nonmetals, we're supposed to be using the most typical charge up top. But what about these metals in the transition metals that have multiple charges? And I said, hold on, we're going to get to it, and that's right now. So I want to actually go ahead and start by showing you two different compounds. Now, again, if you're following along on my guided notes sheet, these pictures are available for you right on your notes sheet. But if not, I am going to pull that up quickly just to show you what that looks like. And so here we go. Here we have two different distinctive looking compounds, okay? We have a red powder and we have a yellow powder. Now, what's particularly interesting about these is that these two different powders are both made from iron and oxygen, okay? And based on what we know thus far, how would we go about naming those two substances, right? So again, based on what we learned in our binary compound video, we name it based on our metal, okay? So iron. And we may name it based on our nonmetal, okay, but by changing the ending to IDE. So iron oxide, okay? Naming our second compound, again, well, it seems kind of silly, but I'm going to show you, right? It's also made from iron and oxygen. So we get iron oxide. But this is extremely problematic, okay? And we note that it's problematic because these two compounds have distinctive properties, right? They're these distinctive red and yellow colors. And because they have those distinctive properties, they each need their own name, okay? So they're both going to need their own name. And so what we need to kind of talk about in today's lesson is, well, one, what makes iron so special? And two, how do we name these so that they have distinctive names? And so I'm going to go ahead and flip back to my notes sheet so that we can take a look at the notes here, okay? So again, our major problem that we're experiencing, and let me just move myself out of the way, okay? Our major problem that we're experiencing is that these two compounds need distinctive names. Okay, and so we are going to look at how do we name these compounds where the metals have more than one charge. So the thing that makes them really special, these two compounds, is that they're made with iron, or Fe. And if you take out your periodic table and you take a peek at element Fe, or element 26, you'll notice that Fe forms a +2 charge and a +3 charge. So it forms two different distinctive charges, which means it's going to combine in a different ratio, right? So for example, if it's iron +2 and it's bonding with oxygen, which is a -2, they're going to combine in a 1-to-1 ratio to form a neutral compound. But if I have an Fe that's a +3 and an O that's a -2, they're no longer going to combine in that 1-to-1 ratio. So we need to take a look at how we can distinguish which compound is which. So iron Fe has multiple charges on the periodic table. And so we're going to use what is called the stock system naming, okay? So we're going to use stock system naming, okay? And the stock system naming, okay, is going to utilize a Roman numeral to represent the charge. So we're going to say utilizes a Roman numeral to distinguish the charge of the FE, okay? So let's go ahead and just write out, just like we did with naming binary, an example of just a general formula of how we're gonna name it. Okay, so let's go ahead and do stock system general formula. Okay, and our stock system general formula is going to be super similar to binary. It's going to be the name of the metal, okay, and we're still going to name the non-metal, and we're still going to change the ending to IDE. Okay, however, in between, in parentheses, here's where we're going to utilize a Roman numeral. So we're going to have the charge of the metal in a Roman numeral. Okay, so we're going to name our metal, we're going to name our non-metal with IDE, and we're going to stick that Roman numeral right in the middle, and it's going to represent the charge on that metal. So I want to make sure before we actually try doing any of these problems that you guys are super familiar with your Roman numerals and what those are. So I'm going to go ahead and start just writing those out for you, okay? So we need to know up to Roman numeral 10. We really only use up to 7, but I mean, why not, okay? So we have number 1, okay, and the Roman numeral for number 1 is just I. The Roman numeral for number 2 is I, okay? The Roman numeral for number 3 is I. Roman numeral for number 4 is IV, okay? So the I before the V is 4. Roman numeral number 5, okay, is just V. Number 6 is VI. So it's always IV and VI that do get a little bit confused, so be really careful about those. Okay, number 7 is VII. Okay, number 8 is VIII. Okay, actually I'm only going to go up to 8. So your paper has up till 10. We're never going to surpass 7, so I don't know. I feel like up to 8 is satisfactory. So those are your Roman numerals that we're going to be using. Now, before I show you how to find the charge on that metal ion, let's do some just practice examples of the different formulas and their names. Okay, so I'm going to leave those charges up there, and I'm going to go through some specific examples. All right, so example number 1. Okay, given this formula, we have FeO. Okay, the name of this substance is iron 2 oxide. Okay, next example, iron 2 oxide. Next example number 2. Okay, we have Fe2O3. So here's those two different ratios, the 1-to-1 FeO and the more than 1-to-1 FeO ratios for those two compounds that we saw above. Okay, so the name of this one is iron 3 oxide. Okay, so we can see from the name that these now represent the charges. This is the charge on the iron, okay, and the charge on the iron. So if I wanted to go backwards from this and go back to formula, we could again use the crisscross rule to do that. Fe, I know from my name that my charge is a +2, O is a -2. We crisscross, we get Fe2O2, which again reduces to FeO, okay? And again, just showing the example with the iron 3. Again, that Fe, the charge is that 3, so plus 3, O minus 2, Chris and cross, and we get Fe2O3, okay? All right, let's do just 2 more examples for names, and then I have to talk a little bit about, given the formula, how can we make sure that we have the correct charge on the metal ion? But again, before we get there, example number 3, okay? This is V2 S5, okay? And the name of this is vanadium 5, okay, sulfide. Now, this one, I love to use this example in class because this actually showed up on a Regents where the state had to throw away the question entirely because they had students, they gave students the name and wanted the formula, and a lot of students just saw this V right here, which again, we know is the charge of the vanadium, but because it's vanadium and V, they thought that just represented the symbol. But again, they're never going to give you the symbol in parentheses. It's always representative of the charge, which in this case, again, means 5, okay? All right, one more example. So example number 4. And this one is COBr3, okay? So the name of this is cobalt. And the charge of the cobalt is a 3. And it is bromide. Okay. Now, here's where the tricky part it's not super tricky, but here's where it it can be kind of tricky for us, is how do we determine the charge of the metal ion? So I very easily knew from the names, just because I'm so practiced in the formulas, what the charges were. But for you guys, it's really important that we kind of have a fail-safe way of figuring out the charges on those metal ions. So in order to determine the charge of the metal ions, we are going to use what's called an SOS table, okay? So to determine the charge on the metal ion, okay, we're going to use what's called an SOS, get it? Like Save Our Souls Help table. Okay. So let me just walk through really quickly what that is. I'm going to do 2 examples, just laying out how we do them. And then when we finish going over that, we're going to do some just practice of just formula to name and name to formula, just so that we are kind of make sure that we're clear. Okay. So to determine the charge on the middle ion, we're going to use an SOS table. So let's go ahead and set that up. If you're following along on my guided notes sheets, I've included those tables for you. If you are not following along on the guided notes sheets, you're going to have to draw these out. Okay, so in an SOS table, okay, we need 3 rows. So we get an S, an O, and an S. And then based on the number of types of atoms present, I'm going to say just always stick with 2. I think I put 3 columns on the guided notes sheets, but we really only need 2 here for the different types of atoms. Okay, and I always like to leave no line in the bottom. Okay, and I'll show you why in just one second. But the first example we're going to do, the chemical formula is CuO. Okay, and so we're going to place a Cu in the first and an O in the second. Now let's talk about what these letters stand for, okay? And let me just go ahead and decrease the size of this so I can fit this in here. So the first S stands for subscript. So in the first row, we are going to place the subscript value from our formula. Now looking at CuO, we are in a 1-to-1 ratio. So both of our subscripts are a 1 and a 1. The second letter, the O, stands for the oxidation number, okay, which is really the same thing as the charge that the ion forms, okay? So for copper, The problem is, if we look it up on our reference table, that it forms two different charges. So we're actually going to say, we don't know the charge for sure on that copper, so it becomes X, like an unknown in a mathematical equation. In case I haven't mentioned this yet, chemistry is very, it's very intertwined with math. We use a lot of math. It's not super hard math, but we do use a lot of math in this class, okay? Next thing we're gonna do is look up the oxidation number or the charge of O, which looking on our periodic table is a -2, okay? And then our last S stands for the sum of, okay? But before we can get to the sum of, we need to complete a little bit more math. Now, what we're gonna do is we're gonna say 1 times X gives us what value? It's gonna give us 1X, okay? And we're gonna do 1 times -2, which is gonna give us -2. So you can see we're well on our way to starting a mathematical equation here. The question then is, what do I have to set it equal to? Well, here's the beautiful thing. This, the CuO, is an ionic compound, which, remember from our discussion in class and our discussion from the videos, always forms a neutral compound with an overall charge of 0. Okay, so I am going to go ahead and star that here, and we're going to say set equal to 0, right? Because the compound is neutral. Okay, and now all we have to do is solve for that X value. So we're going to follow through with math. I know, boo. I love math, actually. Okay, and we're going to solve this out. So we get add 2 to both sides, and we get X equals +2, and therefore the charge on my copper is a +2 ion. Now I want to name it. Okay, so now we know that this Cu up here forms a +2. Oxygen was a -2. Okay, let's go ahead and name it. Okay, so our name now becomes, I'm going to make this a little bit bigger again, copper 2 oxide. Okay, that's how we would name this substance. Let's do another practice problem. Okay, so let's go ahead and draw out an SOS table again. I'm going to put it up a little bit higher this time. Actually, our substance that we're going to do it for is PbO2. We need to have our, okay, okay, we have SOS. Okay, we have a PB and we have an O. So again, first S stands for subscript. So let's go ahead and fill those in. Our subscripts for a PB is a 1. Our subscript for O is a 2. Okay, oxidation states. Again, for PB, if we look it up, it's unknown because there are multiple oxidation states that it can fit. So it's going to become our X, our unknown, and our O is a -2. Now we're going to do our math where we say, okay, 1 times X gives us X. Okay, 2 times -2 gives us 4. And this sets equal to 0. And we're going to get our overall answer of X equals +4. Okay, so now we can actually go back and name our substance. So this is, let me throw that in a different color so that it sticks out. Okay, this substance is lead 4 oxide. Okay, lead 4 oxide. Okay, I feel like we are in a good place at this point to go ahead and just look at a couple practice problems. So let me go ahead and write them out at the bottom. The first two, again, actually, I want to make sure there is something that you should always do when you get a chemical formula at the very beginning. So there's kind of a system to check it first. So before creating, and I'm going to star this, an SOS table, okay, confirm that the metal has more than one charge. Because if it doesn't, then you do not need a Roman numeral and you do not need an SOS table. So let me give you an example of that, right? If I were to give you the following compound, NaCl, right? We've all seen this before. I would go first to my periodic table and say, does sodium form more than one charge? The answer is no, it forms just a +1. If that's the case, no Roman numeral, no Roman numeral is needed, okay? So sodium forms only one charge, and therefore requires no Roman numeral. And if you name it with a Roman numeral, it's technically wrong. So the name of this would just be good old sodium chloride, okay? So let's go ahead now and jump into these examples that I was talking about. So example number 1, okay? Let's say I give you the chemical formula Ag2S. I want you to tell me what is the name of this formula. So here's where we're gonna, and if you want to, feel free to pause and try this on your own first, okay? So pause if you want, 3, 2, 1, pause, okay? If you didn't pause, that's fine. We can walk through it together. If you did pause, hopefully you're back now. Here's where we're going to use our check. First thing we do, check. Does silver have more than one charge? If we look silver up, it doesn't. It only forms one charge. So that actually makes this very easy to name. So again, only one charge. And so its name is just silver sulfide. Okay, let's take a look at a second example. Okay, so example 2. Okay, and again, in this one, I'm going to give you a formula, and I want us to go to a name. So MnCO3. We didn't do one of these above, but we do still need to know how to use those polyatomic ions here. So what we're going to do is, again, what we talked about, we're going to determine the polyatomic ion, which in this case is the CO3, and I'm going to show you just how to treat that. But we're going to do our check first, which is find manganese and determine, does it form multiple charges? And if we look at manganese, element number 25, it forms lots of different charges. So what we're going to have to do here is an SOS table. So this forms many charges. So we need to use the SOS table. Okay, so let's go ahead and set that SOS table up. And again, I'm going to show you how we can use that for a polyatomic ion. So we have our table here. Okay, we have SOS, and we have our Mn. And here's the great thing. Our CO3 is a polyion that we know the charge for. So we're going to actually just keep CO3 as one substance, and we're going to just determine the subscript and oxidation state of that, or charge, okay? So let's go through and figure out all of our subscripts. So Mn is a 1, and here's where I really recommend using reference table E. Again, it looks like there are 3, right, because of CO3, but if you flip to the reference table and locate the carbonate ion right here, okay, our carbonate ion is CO3 stuck together. So remember from what we learned, this sticks together and there are no parentheses, which means that the outside really is just a subscript of 1, okay? Oxidation numbers or charges, Mn is unknown, X. CO3, we can find the charge on reference table E. It's a -2. So now we get our X minus 2 equals 0. And we get X equals +2. And now from here we can name this manganese to carbonate. Okay. All right, really quickly, I know this is a lengthy video. They're going to be like that for ionic bonding, I'm sorry. But I do want to quickly just go through 2 examples of going from name to formula now that we know what that Roman numeral means. So for those examples, I just want to go ahead and use example 3. We're going to have the name. We're going to have palladium, IV, sulfide. And let me just write the last one out so it's just written out. And example 4, which is going to be titanium 3 chromate. Okay, so now that we're looking at these names and I want us to go to formulas, okay, we are going to do palladium 4 sulfide. So palladium, okay, we need to look up what that is on the reference table because I don't even, no, I know. But if you don't know what palladium is, you want to look that up, okay? It is Pa, and we want to know the charge here, but remember the charge is already given to you. It's actually super fast. It's in that Roman numeral, so this is a plus 4, okay? Sulfide ends in IDE, which means it's not a polyion, okay? And we're going to use S, and S's most common charge is a -2. We're going to we're going to cross, and we get Pa2S4. Don't forget that at this point, we can actually slash those and reduce them to just PaS2, okay? And then really quick, titanium 2 chromate, okay? So titanium 2 chromate, I'm going to do that off to the side. Titanium, again, if you don't know it, please look it up. It's Ti, okay? Titanium 3 plus 3 chromate. It ends in ATE, which means I need to look on reference table E for that ion, okay? So chromate, flipping to reference table E, if we find it there, chromate is CrO4. And remember, we always put it in parentheses, and it has a -2 charge. So now we're going to and we're going to cross, and we're going to get Ti2 parentheses CrO4, close parentheses, 3. Okay, thanks for hanging with me, everybody. I will see you in class tomorrow. Have a great day.